All right, good evening, everyone. Thank you for coming here. Thank you, Paul and Michael as well, for inviting me here in Tokyo Dev. It's my first time in Tokyo Dev. I hope you guys like my presentation. All right. Since it's Christmas season, recently, so I changed my theme, an hour ago to a Christmas theme so that it will look like in the season. Hope you like it. My title of the presentation is called "No Script, No Problem." Basically, automation test engineers write test scripts for doing automation tests, and that's why in this presentation, we currently are not doing any automation scripts, but we are leveraging LLM to execute some of our automation tests. Just a brief introduction on myself. My name is Mark. I am originally from Philippines, then moved to Taiwan for a few years, then now working in Japan for SmartNews as an engineering manager. All right, so first things off is with regards to our SmartNews application. So SmartNews application is an app for iOS and Android. We have a highly dynamic content because it's whenever we refresh it, we have new different content every time. And we do have different editions, Japan edition and US editions. Also, we have a mix of native and web view. So you can see here on the top, on the left side, mostly of them are on the native side. But if you can see if there are ads or also the top channel, you'll be able to have some web views in between as well. So also it makes the test of it's make the test a bit tricky because, for example, for Appium, it will be difficult for us to detect the elements on different types of web views. And we also have a weekly release cadence. So every time when we do have a release, so before the release, we execute a regression test. In the past, we execute the test we spend around 50 hours a week to execute this test. So we want to automate as much as possible so that we'll be able to save some time for our exploratory testing. This is the test management tool that we have. We have a regression suite inside. So we have a fixed set of regression tests, and we execute test runs for every release. Then for each of these test cases, it's written in a BDD format or behavior-driven development, as an example there. Then before we execute the regression test manually, we do have, there's a robot there that executes the automation test. We basically focus on test cases that are repetitive and mainly focuses on feature testing. So those types of test case results are passed into our regression test management tool so that once it's in the morning, the manual testers who are ready to execute the test, they will execute the remaining tests and do exploratory testing. So this is how we handle our regression test on a weekly basis. So it was essential for us to increase the automation coverage. So we started with native framework on executing a test. For Android, it was an Espresso. For iOS, we use XCUI test. It was working great. It was running fast, and it was pretty stable. But the problem there is that as mentioned earlier, we didn't have a very good execution of WebView because the elements there are not visible. So especially for XCUI tests, when we try to execute some tests that are WebView related, it was difficult for us to execute these tests. So we move on to Appium. So maybe you've heard of Appium as well. For Appium, it was a ideal automation framework for us because it was connected. We can use the same code for both iOS and Android, ideally. And then it was executing it on a person's point of view. So it was very nice. However, when we executed Appium, it was extremely slow and extremely flaky. So we spent a lot of time maintaining these tests, and then after wait maybe a few days or a few weeks, these tests fails again, and then we need to update the script every single time because um it's basically very flaking. So it was hard for us to increase the coverage. Our problem, we got a automation coverage ceiling of around 40 to 50% of our regression tests, and it costs us a lot of maintenance. We manage a lot of test cases. It was a bit hard for us to manage these test cases. So we only have around 2 to 3 engineers working on these test cases, and we spent a lot of time updating the tests every time. Whenever there is a new feature, then we need to update it again. So it was a lot of effort. So that time, I think maybe a year ago, we had an idea to maybe because yeah, a year ago where LLM or ChatGPT was really popular and everyone was using it, we had an idea of why not ask ChatGPT to think of means to execute the test on its own. So the idea was because we do have the test cases written in BDD already. So for example, finish onboarding, then we ask LLM to execute the test for us by providing it some information, and then it will complete the task on its own. So we spent 2 weeks, I remember, like a hackathon style in running this experiment. So we had a LLM. We use either OpenAI or our internal AI platform tool. We gave it a set up a prompt, provided a simple test case, and we gathered some tools for the LLM to use. These tools are for LLM to be able to retrieve. Of course, we need to let the LLM see what the application looks like. At first, we wanted to provide a screenshot. However, screenshot might be misleading for LLM. It was better for them to read through the text directly. So instead of providing the screenshot only, we also provided the page source. So page source is sort of an XML file wherein we'll be able to see the X and Y axis of different elements. And in that area, LLM will be very clear of where the elements are located, and it's lot it will able to decide better with the text comparing it with using the images. And then also we added a tooltip tab. So of course, once you want to control the application, we added, what do you call that? ADB and IDB for both Android and iOS to execute the top functions so that it will be able to tap on the phone and make some movements on the application itself. So it'll be able to control the application. So with the early experiment we have, we use the reasoning in action. So this is like a screenshot of the first prototype that we have. And we're able to go through the onboarding process smoothly. So you can see here the reasoning and the action that it's making for each of the steps. And it was able to run through in our onboarding, basically there's like birth, and then what's your sex, and then continue on to move to the next, what's your maybe categories and so on, what type of news that you like. So these onboarding flow, it was able to complete the onboarding and be able to see the home tab successfully. So you just 2 weeks of experimentation of it, we were able to successfully complete the onboarding without script at all. So with that, we were able to see that it's very promising, and we wanted to spend more time in improving this tool so that we'll be able to use it for our regression tests. So that gave birth to TARS. TARS is, if you don't know, is from a movie called Interstellar. I don't know what it is really called. I forgot, but TARS for us is Test Automation Regression System, which basically helps us to execute the test. So we use LangGraph to set some stateful orchestration so that it will be clear and scalable in implementation of our agents. So this is the tech stack that we use. So basically we use TypeScript, LangGraph, and then GPT 4.1. At that time, I think it was 4.0, and then now we are using 4.1. We increase as well the tools that we use. So we have type, swipe, input, and getting the page source. So within the 3 months that we had TARS, we have 60% automation coverage, near zero automation maintenance. So we didn't do any maintenance. It was very straightforward. Once we added a tag inside the feature file of the test cases, TARS just run through the test case and it was able to execute the test properly. So with that, manual QA was able to even run the automation tests on their own. So if they wanted to create a new test case, if there was a new feature, then manual QA just needed to write a test case in BDD format. It's readable. And TARS can read these feature files and it's able to execute it properly. So it was a very ideal win for us. But we do have some problems. So we had a big problem with accuracy. So once we use LLM, it was hallucinating a lot. So it was trying to do different things even though we didn't say it what to do. So we measured the accuracy of TARS and it was pretty bad. So it was around 45%. So basically there are a lot of tests that maybe passed that probably should have failed and vice versa. Also with regards to the prompts, so when we started TARS, we didn't have any systematic prompt saying that SmartNews is a news application that will be able to provide clear information of what type of features the SmartNews have. So we tried a lot of improvements on the prompt so that it will be able to have a better idea of what it's testing on. So our new challenge there was now is improving the accuracy. But before that, we needed to define what accuracy is. So with accuracy basically it means that if TARS is able to determine whether the results of the test is correct or not. So we have a true negative, true positive over the total. Basically what it means is that true negative means it's passing and then there is not able to find any bugs in it. While true positive means that it failed and it was able to find an actual bug. So other than that, we want to isolate false positive and false negatives. So with that, we did a lot of improvements in taming TARS. First of them is we did a lot of experiments in improving it. We have a few ones here, like few shot prompting, self-consistency, and using different types of models. And then we also did a retry mechanism. So when TARS executes the test, when it fails, it tries to retry. Also improve the tools improvement using Maestro instead of Appium because it's able to have better customization. And also the swiping tools, we also did some improvements there. So we created a benchmark testing. So if you can see on the left side are the list of test cases, and then we try to measure each type of experiment that we use, and then run it 5 times. So if you can see here, this is just a sample of the results that we had and trying to experiment on different areas. So you can see there are a lot of runs there and try to check whether the accuracy is good or not. So after doing a lot of experiments, we ended up, sorry. So after doing a lot of experiments, we ended up having a very good accuracy, and we decided to add a agent called Auditor. So before we only had a test title, test logs, and fail screenshot to do the troubleshooting. But it was very time consuming for us to gather these failed test cases. So you can see here, we only received this information from the TARS, and we don't know what happened. But we added this auditors for us to increase the readability and understandability of the logs. So you can see here now, we added this auditor agent so that we'll be able to identify if the decision made of this failed test case is correct or not. With that, we'll be able to see here that it's actually writing Apple instead of we're trying to write in the keyboard Apple in English, but the keyboard is actually in Japanese. This is basically the multi-agent operation graph that we have so that we'll be able to run the test and then execute the auditing and make sure that the accuracy of these tests are good. With this model, we're able to increase our accuracy. So right now we are able to have a coverage of 80% and 90% of accuracy. So this is an example of a run that we have. First one is going through the onboarding flow. And then we also printed out the reasoning at the bottom so that we'll be able to see how it is thinking or what it's thinking, what's its next step. So here you can see that it was able to successfully do the onboarding, while this one is on looking into the different tabs. So we have in the lower part, there are 5 different tabs. And basically what we are asking TARS to do is to check each tab and make sure that the content of the tabs are as expected. Then finally, this one is for the login flow. For the login flow, we added a new tool for checking the email address because our login flow has an OTP for it. So we needed to really check whether whether the OTP is, to be able to receive the OTP, we need to check the email ad. So we created a dummy email address and we able to get the email. So once we get the email of the OTP, we're able to enter it and log in successfully. Anyway, what's next for us is currently we are trying to improve the reliability of TARS. So what reliability is that it's supposed to fail when it's a fail, and then when it's supposed to pass, it will pass. So we try to are currently trying to measure it. So we set up some golden test cases and execute TARS against these golden test cases and make sure that they are reliable and the test results are correct. Then also we do have cache mechanisms for these steps. So because we kept on asking TARS what to do next, what's the next step, for every time, we are executing these test cases on a regular basis. And test cases usually doesn't change much over time. So it would make sense, a lot of sense, and maybe will save a lot of time and cost as well if we are able to store these steps, given that we do have these page sorts, the same page sorts and same test case. So given when we are able to store this cache mechanism, then we will just grab it, the next step, and then let TARS execute it directly without asking OpenAI or LLM. Then we also are currently working on to run it on web platforms. So right now we're able to have some web platforms running again on TARS. So basically we enable TARS to run Playwright test cases, Playwright, so that it'll be able to execute some tests on the web application. So it's a lot simpler to execute it on the web applications because it's more easier, stable for us to just run that on the web compared to mobile applications. So it's way easier for us. So we spent very little effort in applying this, but yes, we do have TARS able to execute some tests on the web. And lastly, we do have also measure the metrics and alerts so that whenever there is a unexpected failure in the specific version of the application, then it will give us alert and we'll be able to see the history of the failures of running these test cases. Yes, that's it for my presentation, and thank you very much for listening.